All right, this problem says a cheetah can run at a maximum speed of 109 kilometers an hour, and a gazelle can run at a maximum speed of 78.3 kilometers an hour. Both are running full speed, gazelle 90.2 meters ahead. How long before it catches its prey? Okay, so basically what's happening, I'm not trying to draw cheetahs and gazelles. So the cheetah is here, and the gazelle is here, right? And the gazelle is ahead by 90.2 meters. And both these things are going to run for some distance, right? And right here, the cheetah catches the gazelle and bad things happen, right? He's dead. I spent all that time doing that. So anyway, you want to find how long this takes for both these things to happen. Okay, so for me, the easiest way to solve this is to draw a graph because both these things are going at constant speed, right? So I'm going to draw a position versus time graph. So this is time, and this is position in meters. And before I go do this, right, the first thing I need to do is turn my kilometers per hour into meters per second. I need to do that first, okay? And the way to do that, you could either, right, like you could look it up the easy way, just go to Google, or, right, kilometers to meters, I would multiply by 1,000. And then hours to seconds, there's 3,600 seconds in an hour, right? Because 60 seconds in an hour, 60 minutes in an hour, 60 seconds in a minute, 60 minutes in an hour, Christ, right? So 60 times 60 is 3,600. So I could multiply my 109 and my 73.8 by 1,000 over 3,600 to give me meters per second. I can't go solving in kilometers per hour because my answer is in seconds and this one's in meters, right? It's not going to work. So now I can go graph this, right? So let's do the cheetah first. I'm going to say the cheetah starts at the origin. So here's my cheetah. So this is my cheetah graph. And the gazelle has a head start, but he runs slower, right? So I'm going to have a y-intercept for the gazelle. So this is going to be 90.2. And the gazelle is going to run slower, so his slope is going to be smaller, and it's going to look like that. So there's the gazelle. And at that point right there, that's delta x. And that time, this is when Animal Planet happens and the cheetah eats the gazelle, right? So I basically have to take some equation and figure out the time for these two. So what I'm going to do is I'm going to write the equation for both of these lines, right? In the form of y equals mx plus b, right? Because these are linear slopes, right? So y is x is t, right? I mean y is displacement, I should say. X is time, m is the slope, b is the y-intercept, right? So let's do the cheetah first. So the cheetah is delta x equals my slope for the cheetah. Slope is the velocity, right? So I'll call that velocity cheetah times the time, so times delta t. So there's my equation, y equals m times x. And m, the slope, is how fast the cheetah is, which is that, right? Okay, so now let's do the gazelle. So for the gazelle, same thing, delta x equals, slope is the velocity for the gazelle, right? So this number, my second number, times delta t, but this one has a y-intercept, right? This one has a 90.2 meter head start, so plus 90.2. So there's my two equations. So here's what I'm going to do. To get rid of this delta x, which I don't know, I know that delta x is the same, right? So I can set these two things equal, and basically I'm going to like flip this equation around so that I get rid of all this and I just say that equals that, right? Because they're both delta x. So I'll say velocity of the cheetah times delta t equals velocity of the gazelle times delta t plus 90.2. Now I got an equation that only has one unknown, right? Because I know my cheetah velocity, I know my gazelle velocity, right? I took them and I converted to meters per second. Hooray, we're basically done. All right, so let's do a little bit of algebra. So subtract this over. So velocity cheetah delta t minus velocity gazelle delta t equals 90.2, right? Okay, so from here, I need to get these terms together, right? So let me remove a delta t from both of those things. So Vc minus Vg equals 90.2. So, right, if I distribute the delta t in, it would go back to the way it was. But now I only have one delta t. And so from here, I'm going to leave you to do that algebra, right? So you could plug in your cheetah velocity, your gazelle velocity, your intercept, right? And you could do the algebra to solve for delta t. And then that, when you solve that, that's your answer for number 1. Okay, so for number 2, the question is, they both run for 7.5 seconds. How far ahead does the gazelle need to be since the cheetah can only do that top speed for 7.5 seconds? So here's what we need to find. We need to find delta x for both of them in 7.5 seconds, right? So we're going to find how far each of these animals goes in 7.5 seconds. So let's do the cheetah first. So the cheetah, for both of these, right, velocity is delta x over delta t. So if I want to solve for delta x is velocity times time, right? So I'm going to do, for the cheetah, I'm going to do the velocity of the cheetah times delta t, which is 7.5. And that'll give me delta x for the cheetah. And then for the gazelle, I'm going to do the same thing. Velocity of the gazelle times delta t, where delta t is 7.5, right? And that's going to give me my delta x for the gazelle. And so in these two times, because the cheetah is faster, right? So here's the cheetah and here's the gazelle. The cheetah is going to cover more distance in 7.5 seconds, right? So the gazelle needs a head start of that. That's your answer. That's how much ahead the gazelle needs to be, right? So if you get your cheetah distance and you get your gazelle distance, right? That difference is how far the cheetah needs to be ahead, and you can solve that.